Hello and welcome to the 1998 AP Calculus AP FRQ questions. This is question 3. So let's start. A. During what intervals of time is the acceleration of the car positive? Give a reason for your answer. So basically what's important to remember here is that the velocity and the acceleration are going the same direction. So this whole thing is when velocity is positive, and so now we just need to find when acceleration matches that and is positive, aka increasing. So we see here all the way from 0, look, it's increasing until we get to 35, and then it decreases, and then from 45 to 50 it's also increasing. So basically what we can say is from 0 to 35 as well as 45 to 50. Oh. Though we should also include that it is because, I'm just going to write this in shorthand, because velocity, here I'll write positive velocity, I'll do velo is increasing. Part B, find the average acceleration of the car in feet per second squared over the interval of 0 to 50. So basically what you need to remember for this, if you're a physics person or however you want to remember it, you need to remember that average acceleration, we'll just do AVG down here, is the change in velocity over the change in time. So since it's over the time of 50 to 0, 50 minus 0, we have time is going to be 50 here, and then we're going to have velocity, we take the final minus the initial. It's easier to look at the table, that's nice here. And we have 72 minus 0. So that's just going to be equal to 72 50ths. Okay, now in part C, we are trying to find one approximation for the acceleration of the car in feet per second squared at time equals 40. And they want us to show the computations used to arrive at this answer. This question, probably you wouldn't see something like it now. You might see something a little bit different. You might want to actually find a tangent. But for this one, it allows us to do some approximation. And the way I'm going to do it is I'm going to take T45 and T35 since we're trying to find 40. And that time is in the midpoint of it, and it will give us, if you think about a tangent here, it gives us an okay approximation. So to do that, again, we're using that same formula of A equals change in V over change in T. So what we're going to do is we're going to say a V of 45 minus V of 35 divided by 10, because that's the difference in our 2 times here, 45 and 35, 10 seconds, is going to be equal to, let's see, V45 is 60 minus V35 is 81 divided by 10, and I'm just going to leave units off for now, it makes it a little easier for myself. And now we have negative 21 tenths as our answer. But let's put the units back on. And feet, it gives us the units, how nice. Feet per second squared. And there is our approximation. You could take a different approximation. You could take it from 40 to 45, 35 to 40, or if you find the tangent, that's also acceptable. This question is pretty open. In part D, we are asked to approximate the integral of v of t dt with a Riemann sum using the midpoints of 5 subintervals of equal length. So that's really important there. And then we're going to use the correct units, and then we're going to explain the meaning of this integral. So what is integration? We're trying to find this area under here. That's a horrible shading of the region, but you get the point. And to do this, we're using a Riemann sum. If you don't remember Riemann sum, you're going to be basically adding a bunch of things up and multiplying times how long you're going to do it. And we have 5 subintervals. We have 50, so divide that, and look, each subinterval is going to have 10 difference between it. So we can go this way. We have 0 to 10, then we're going to have 10 to 20, 20 to 30, 30 to 40, and 40 to 50. And it's really nice in this one because we're finding the midpoints of these 5. And look, between here there lies, what's between 10 and 0? 5. So there is one midpoint. It's between 10 and 20. Here's 15, 30, and it just goes on like this down through the rest of the pattern. So these numbers are going to be plugged in. So instead, I'm just going to factor 10 out, because if you remember, it's going to be each interval times the sum of these things. So this would normally be 10 times 12 plus 10 times 30 plus 10 times 70, but it's a lot easier if I just do it this way. So we have 10, and we factor that out, and we have 12 plus 30 plus 70 plus 81 plus 60. Okay, so this is 100 here. You have 181 like that. Then I suppose we can add this now, which is going to give us 241, 253, I think. 253 times 10 is going to give us 2,530. Yep. And now we're going to put on the proper units. So if we have this velocity and we're taking the integral, what are we really doing? We're trying to see how many feet, because this is in feet per second. This person traveled over this whole time. So the answer is going to be in feet. And if we want to explain it a little bit, it would mean that they traveled, the car traveled that many feet. Exclamation point. That's a lot of feet. Alright, thank you for watching. Make sure to subscribe, and I'll see you guys in the next review video.